So what are the difference between gram-positive and the gram-negative bacteria? The major difference here, if you know that, is because the color stain. So in the gram-positive is stained blue and the gram-negative is stained red. Why is that? Because to keep it simple, you'll see that during the staining, first of all, you're gonna give the blue dye here, and then you're gonna wash it off, and then you're gonna give the red dye. In the gram-positive, since it has a very thick layer of the peptidoglycan, as you can see in here, so it's gonna retain the first color that we gave, which is the blue dye here. So even when you wash it off, it actually kind of retain it, so it doesn't bind the red dye in the last step. For the gram-negative, because it has a very thin, as we see in here, very thin peptidoglycan layers, so it actually doesn't retain the blue dye after we wash it off, and you're gonna retain the red dye. So that's why is the gram-positive is the blue and the gram-negative is the red. And as we notice that the gram-positive has a very thick layer of the peptidoglycan, right? And the gram-negative has a thin layer, as we see in here, very thin layer of peptidoglycan. So in the gram-positive, the thick peptidoglycan actually is the outermost layer of the bacteria wall. But in the gram-negative, the outermost layer is not the peptidoglycan, but is the LPS, which is lipopolysaccharide. Another fact about the peptidoglycan is that it is catalyzed by transpeptidase enzyme. It also known as the penicillin binding protein, because it is the target of the penicillin. So penicillin actually inhibit the transpeptidase to catalyze the peptidoglycan. So substance that has a low molecular weight actually can pass peptidoglycan, such as antibiotic. And for the lipopolysaccharide, it actually can block the passage of the antibiotic that attack the peptidoglycan. So the substance cannot pass, such as the penicillin. And here you see the structure of the lipopolysaccharide. So it actually has three substructure here. Here number 1, and number 2 is this part, and number 3 is here the purple color. Here is the lipid A, or the enterotoxin. So when bacterial cells are lyzed by the potent immune system, it might release the enterotoxin and cause the septic shock.